Hi everyone, welcome back. Today we're doing keyboard row. So for this question, we're given an array of strings, and this is assigned to these variable words. We have to return the words that can be typed using the letters of the alphabet on only one row of the American keyboard, like in the image below. So the first row in this case is this row over here, QWERTYUIOUP. And the second row similarly contains all these characters over here, and the third row contains the characters over here. So over here, we are only concerned with the words that can be formed with only the first row. So for example, if we have words equals to hello Alaska, that piece, Alaska and that, Alaska in this case can be typed using only the second row, so Alaska. That is DAD. So in this case, Alaska and that are valid because both of these two words can be typed using the second row. For the other words, hello, this is HE. So notice that in this case, we are using two rows over here, so we know hello is not valid. For peace, PEA, so E and A are on two separate rows, so in this case this is not valid, so we get Alaska and that. For the second example, we have OMK, so OMK requires all three rows, so this is not valid, so we return an empty list. For ADSDF, in this case this is valid. SFD, both the first and the second word over here requires only the second row to type, so both are valid. So for each of the words, so this words list given to us has a length of 1 to 20, and every single word in this list has a 1 to 100 characters, and each word in this list consists of only English letters, both lowercase and uppercase. But in this case, we do not really have to worry about lowercase or uppercase because they're only concerned with whether the letters can be inside here. But of course, to make things easier, it would be nice to lowercase all of the words before we check if they are in either of the three rows over here. So let's see. Okay. One way would be to store all of the words into one set. So we will have one set to contain all characters here on the first row, another for the second, and one final one on the third. And we're using set here because set supports O1 search. So it's very fast to check whether if a given character in words over here exists in either of the three rows. And the idea is we will iterate through each of the words inside this list. And for each of these characters that we see, we will try to determine if it exists in the first row, second row, or the third row. And we will use the first character in each words as the anchor for whether if we should continue to use which set for subsequent characters. And as we go through all characters in each of the words, if it happens to appear in another different row or it doesn't exist in the current row that we have, then we will just terminate our search scan across this word and move on to the next word. If a word contains only characters inside that one set, then we will increment a helper variable that keeps track of the number of words that exist on each row. So that was quite a mouthful, and I'll be articulating this strategy with an example. So let's say in this case we have words equals to hello Alaska, that piece. This would be our test. This will be our test case 1 in this case. We can have top row. Let's call this first row. First row will contain a set of strings, and this set will contain Q, W. Actually, we can use this curly brace syntax for defining a set as well. So Q, W, E, R, T, Y, U, I, O, and P. So we initialized a first row set that contains all characters in the first row. And now we'll be doing the same for the second and the third. So second row and third row. So we'll do A, S, D, F, G, H, J, K, and L. And we're done with the second row. Let's do the same for the third row. Populate all characters in the third row inside this set. V, B, N, M. So that's pretty much it. So Z, X, C, V, B, and M. Okay, that's perfect. So now that we have these three rows, let's put each of these rows inside. Would it help if we put this inside a list? Yeah, that would work. So let's call these all rows. This will be a list of set of string. And let's set these to be equals to first row, second row, and third row. And if we want to save space, instead of defining a separate copy for each of the first row, second row, and third row, we can shift all of these definitions inside all rows itself. So this would be okay. And just like this, it will be easier for us to iterate through each of the keyboards. And we can use the index to all rows to determine whether if it's the first keyboard, the first row, the second row, or the third row. And once we're done with all rows, we can start iterating each of the words to determine which row is this word supposed to belong to. So let's do for word in words. And we will first determine the row for this current word. So this is the anchor character. The anchor character is the first character in each word. So we'll set this to word at 0. And just to check that each word has at least one character, yes, that's true. So this would be safe. We will not encounter any out of bounds exceptions over here if we access the first character. So we also define another helper variable. Let's call this valid. Let's call this valid word. And this valid word indicates if this word is only consisting of characters belonging to one row. And if that is not the case, we will set this to false later. We will also define a helper keyboard words. Actually, let's call these keyboard words. This will be the final answer that consists of only words that have characters on one single row. So now that we have this anchor row, the next step is to figure out which keyboard does this anchor character belong to. So for row in all rows, okay, so let's do current row equals to, actually this would be fine actually. Yes, let's just define this to be a set of a string, and let's initialize this to be an empty set for now. We will set the current row to the row that contains the anchor character. So if anchor character is in row set, so row set, then we will set current row to be equals to row set. And we will be using this current row for subsequent checks for all other characters existing inside this word. So now we will do for char in word from the second character onwards, because we have already checked the first anchor character. It's okay for you to just iterate through from the start again for simplicity, but in this case, because we notice we can do that, we just did that anyway under interview conditions. So if char not in current row, then we will do valid word equals to false, and we will break. So if we notice that any of the one characters doesn't belong to the current keyboard row, then there's no need for us to continue the search because we know that the word is already not valid. So we are just breaking that search to save runtime. So at this point, after this search, we can check if the valid word, then we will append this current word into keyboard words. So we will just append this current word into this final result, and we will return that. And that's pretty much this strategy over here. So let's try this out with this very simple test case that we saw earlier. So the expected result is Alaska dead. So let's just put expected over here. And let's get tracing. So keyboard words is currently an empty list, and we will continue with the first word in the given input. So word is equals to hello. We'll continue. Valid word is now equals to true. And the anchor character is H. Oh, thanks to the tracing, I noticed that I made a mistake over here. I should have lowercase these words over here. So our current rows consist of only lowercase characters for simplicity. So what this means is that before we iterate through the characters, we should also lowercase them as well. So let's do lower word. Let's set this to be equals to word.lower. And in this case, lower word will be set to hello. And the anchor character will be using lower word instead. So this will be lower word, lower word. And we will append word instead because we want the final result to contain the unlowered word over here. So now we have lower word, and we will continue tracing. Valid word is equals to true, anchor character is equals to H because we're using the lower word over here. Current row in this case will be an empty set for now. We will set this in a bit from line 20 to line 22. So this is an empty set right now. I'll just leave it like this. The row set is currently the first one over here. So I'll just, for simplicity, I'll just leave the index of the current row that we have. So anchor set, does anchor character exist in row set? The current anchor character is H. So does this exist over here? No. So we continue to the next row set, which is the second one. And we found out that H in this case exists. So this is true. So we set the current row to the row set. So we will set this to current row. I will leave this here so that it's easier to see. And let's move on to line 24. So now we are checking for subsequent characters in ELLO if they are in the current row. So char is now equals to E. Now let's check if E is in this row over here. So in this case, this is not in the current row. E is actually in the first row, so this will be false. Sorry, this will be true. This expression here will be true. So valid word will be set to false, and we break and we continue over here. Since valid word is not true, so we will skip this step and we will carry on with the next word. And the next word is Alaska. So now the lower word will be ALASKA. Valid word will be reset to true again. And the anchor character in this case would be A. The current row is now initialized to an empty set again. The row set is now equals to 0, like the first row over here. So now let's check. Perhaps it's better for me to just be more verbose and just list out the whole row set like this so that it's easier for us to trace. So let's remove this. Let's just use this to trace. So now let's check whether if A is equals to this row set. In this case, it's not. So we will set row set to the next row, which is the second row. And now we realize that anchor character is in the second row set. So since this is true, we will set the current row to this over here. So let's continue over here on line 25. Now we will continue with the second character in Alaska, which is L. This is L. And character in this case, we check if L exists in this current row. So this exists in the current row is over here. So this is true. So this is false. We will continue with the next character, which is A. And we will check if A is in current row. And it is. So this is still false. We will continue. Let's go to S. Let's check if S is in current row. This is still false. Let's carry on and give it K. Character is now K. K is still in current row, so this is still false. And let's reach the final character in lower word, which is A. And in this case, A exists in current row as well, so this is still false. We don't break, and the valid word is still true. So in this case, we will append keyboard words with this word, Alaska. So Alaska. And we continue. So now we have that. DAD, lower is DAD. We'll reset valid word to true. Anchor character will now be D. And let's reset current row to an empty set again. And let's assign row set to the first set in all rows. So let's do row set equals to this. So let's check if anchor set is in this first row. The first character here is D. So in this case, this is not the right row set. So we will move on to the next iteration on line 22. Now we're looking at the second one. And now in this case, we notice that D is indeed in this current row set. So we set the current row to be equal to this current row set. So there's also one thing that I noticed that I could have done. I could have just break this search after we found which row this anchor character belongs to. There's no need for us to iterate to the next row. So I missed this during the first round of tracing, so thank goodness we noticed this. Let's go to line 26 for character in lower word. Now this is pointing to A in that. So let's check whether if A is in this current row. In this case, this is in the current row indeed, so this is false. Let's move on to the final character, which is D in that, the final D. And in this case, D is not in, this is in current row, so this expression is false and we finish. And in this case, because valid word is still true, we will append that to keyboard rows. And now we are finally at the last word in words. So now the lower word of peace will be peace, and the first anchor character will be P. We will reset current rows to an empty set. And we will set the row set to the first row over here. So we will now check whether if P exists in this one over here. So in this case, it does. So the first row that we're looking for is this one. So let's set the current row to the first row in the keyboards. And we continue. So we break, we assign this and we break. And now we're at line 26. So now we are looking at E. And now we're going to check whether if E exists in current row. In this case, it does, so this is still false. Let's move on to A. In this case, we notice that A doesn't exist in current row, so we set valid word to false and we break. And in this case, because valid word is not true, we skip this step. And we finish with this answer, Alaska Dead, which is the same as expected. So we traced out our solution and it looks like it works. Now let's start coding it out. So to save time, fortunately, we already coded it here. So I'll be defining all rows by copying and pasting our solution in the trace. Let's define keyboard words to keep track of all words to be returned later. And we start iterating all words in the input words over here. So for word in words, we now get the lower word representation of this. This will be word.lower. And let's set this valid word boolean to be equals to true for now. We will override this if we notice that there's a character that doesn't exist on the current row. The next step would be to get the anchor character. The anchor character, once again, will be used to determine which keyboard row we should use. So this will be lower word at index 0. And we will start defining current row to be a set of string, and we'll initialize that to an empty set for now. We will start to iterate through all rows set in all rows in a bid to figure out which row this current anchor character belongs to. So if anchor character happens to be in this current row set, Then we will set the current row to this row set, and we will break the search because we are already done finding the respective keyboard row for this string. So at this point, we will start to iterate through the remaining characters in lower word, starting from the second character. And if the character is not in current row, then this word is not valid. So valid word will be equal to false. We will break the search because we already know this word is not valid. But if this whole for loop from line 50 to line 53 still goes through, in other words, the word is valid and all characters exist in that given row, then we will append these keyboard words with this current word that we have over here. And at this point, our final job would be to return this as the answer. And that's pretty much it. So let's quickly trace this out again to be sure that there's no errors. QWERTYUIOP. This contains all characters in the first row. ASDFGHJKL. This contains all words in the second row. ZXCVBNM. This contains all characters in the third row. We initialize the final list to contain all words, and we start the linear scan across all words on line 15. We lowercase them because the constraints mention that every single word can be uppercase or lowercase. So we have to be careful to lowercase it so that we can check for their corresponding lowercase characters in all rows on line 8. We initialize line 17 to keep track whether if the word is currently valid. And we define anchor character to be the first character in the lower word. We use this anchor character to figure out which keyboard row this word should use by iterating through all rows on line 8. And if the anchor character belongs to any of the rows set, we will set the current row as that keyboard row and break the search. And our final job will be to iterate the remaining characters in word to check if they belong to this current row. And if that's not the case, we will set that as not valid and we will not append that in keyboard words. Otherwise, we do that. Looks great. Let's run this against the sample test cases. And let's submit this. And there we go. So let's go through the time complexity. In this case, we go through all words. So let's initialize n to be the length of words. And let's define s to be the length of each word in words. So in this case, we are iterating through all words. So this is going to be on in time complexity. And we lower all of them. In this case, lowering all words in a character technically is OS because we have to go through all characters in word to lowercase it. And in this case, this is all O1 operations. We define the current row and we are currently going through all row sets. This is O1 because we will just iterate it up to 3 times, regardless of the size of your S or your N. In this case, this will always iterate 3 times. And anchor character if anchor character is in row set, then this break. Anyway, this is O1, so we can skip this. And now we are proceeding to iterate through all characters in lower word to check if they exist in current row. Thankfully, we use a set, so this check is O1, but this is OS regardless because we have to iterate through all characters. So these operations here will scale linearly with the length of each word. And we append them. Append is O1 operation. So in summary, the time complexity is On, and every single operation for each word is O2S. So O2OS, but if you remove the coefficients, it will just be, this will just be 2NS. So in this case, yeah, this is just n times 2s, right? So if you remove the coefficients, this will be a time complexity of ONS. So let's look at the space complexity next. Let's remove all the workings for the time complexity. Whoops. Okay, so over here, we keep track of keyboard words. So it's going to be ON. I mean, of course, if you count the space of each word, then it's going to be ONS, because every single word is going to contain S characters. So this ONS. And in this case, a lower word is a copy of words, so this OS. And the anchor character, this is just one character, so this O1 is okay. The current row will be of fixed size to either one of these rows, so this is O1. So this current row will not scale with N or S in this case, where N is the length of word, S is the length of every word. So row set in all rows looks good. Character in lower words. Keyboard words dot append. Yep. So in this case, the space complexity is just ONS. So if you increase the length of each word, then these keyboard words will inflate in size as well. And the time complexity, in this case, if you increase the number of words linearly, keyboard words will inflate in terms of memory required to store them as well. So that's pretty much it for this question. So I hope this was useful. If you like this, please give us a like and subscribe, and we will see you in the next video.